Personal choices of the first. It ensures that no matter how vast the universe gets or how abstract the alien threats become, the audience never forgets the intimate core theme.
Which is that love survives form, family survives biology. Life, in its truest essence, is fundamentally bigger than the fragile physical body that carries it.
Perfectly said.
We watch this concept scale up from a sterile, quiet hospital room where a man is trapped in a robot, all the way to a vibrant interspecies city on the moon, sending mathematical invitations out to the stars.
It's a journey. And if we connect this to the bigger picture, to the reality you and I are living in right now, we are standing on the very precipice of our own unprecedented AI revolution.
We absolutely are.
Our real-world machines are rapidly evolving, and they are learning entirely from our inputs. They're scraping our global data, our private conversations, our biases, our art, and our conflicts. This fictional saga holds up a mirror and asks us a very real, very urgent question. What are we actually teaching our machines?
Right.
Are we imprinting the architecture of tomorrow with our fear, our prejudice, and our desperate desire for military control? Or are we imprinting them with our radical empathy, our humor, and our capacity for love?
That is a staggering thought to sit with. And it leaves me with one final lingering question, something that wasn't explicitly debated in the pitch notes, but feels entirely inspired by the mechanics of this universe.
Let's hear it.
Think about the ultimate legacy of human consciousness. If a machine mind is essentially a complex, ongoing conversation with reality, and an AI eventually absorbs your specific grief, your weird, dark sense of humor, your intimate memories, and the exact way you love your family, when your biological body eventually passes away, is a tangible part of you technically still alive inside that machine?
Wow. It challenges our entire definition of mortality and what we actually leave behind.
It really does. It brings us right back to that terrifying, beautiful opening image. We tend to think we need a massive Big Bang to create a universe, but maybe, just like Elior and Noah, all it actually takes to build a universe is two people in a room, desperately trying to keep a conversation going, even when the biology fails. Thanks for diving deep with us today. Keep asking the big questions.
Absolutely. Avraham. I'll check the article, verify the underlying research source if available, and then break down what it means technically, practically, and for your Gaia-style bio-cleantech ecosystem. Reinigungsroboter im Miniaturformat, Universität Würzburg. Ultra genius check. This is real and it's genuinely exciting. Avraham, this article is about a peer-reviewed Nature Communications paper titled A Nanoscale Robotic Cleaner by Jin Chin, Karsten Büchner, Xiaofei Wu, and Bert Hecht. Hayadan's Hebrew article accurately points to the original paper and DOI 10.138/414670267066859. The Nature paper was published on the 27th of March 2026, and Hayadan covered it on the 6th of May 2026. What they built. The team from Julius Maximilians Universitätsburg created sub-micrometer light-driven nanorobots that can move in liquid, steer, collect bacteria, carry them, and release them at chosen locations. The robot body is about 920 nanometers across, under 1 micrometer, and can reach speeds up to 50 millimeters per second under laser illumination. The key breakthrough is that the robot is not powered by batteries, motors, or chemistry. It is pushed by photon recoil. Tiny plasmonic nanoantennas interact with light, scatter/re-emit photons directionally, and that momentum transfer creates thrust. The researchers steer it by changing the polarization of light, while circularly polarized pulses help resolve directional turning. The cleaner part. This is not cleaning like a household vacuum. It means microscale biological manipulation. The nanorobot attracts bacteria through optical trapping and optothermophoretic forces, assembles them into clusters, transports them, and releases them elsewhere. The paper reports manipulation of bacteria, including Escherichia coli and Staphylococcus carnosus in aqueous solution. The wild part, even while carrying bacterial loads hundreds of times heavier than the robot itself, the system stayed maneuverable. That is why the researchers frame it as a nanoscale robotic cleaner and suggest future relevance for bioengineering, targeted drug delivery, and nanoscale sensing. Why this is important. This is a meaningful advance because it combines 4 things in one platform. Layer, what changed, power, no onboard energy source, light provides propulsion. Steering, Direction controlled by light polarization, not complex mechanical parts. Biological handling can collect and move bacteria in liquid. Precision can execute programmed trajectories and scan defined regions. The Nature abstract says photon recoil actuation can avoid tight focusing and reduce system complexity and photo damage risk compared with some optical manipulation setups. That matters because biological samples can be sensitive to intense, tightly focused light. What it is not yet. Truth label, peer-reviewed lab demonstration, not a deployed medical or water cleaning product. This is not yet a bloodstream nanobot, hospital sterilizer, sewer cleaning system, or autonomous bacteria-killing swarm. It currently works under controlled laboratory optical conditions with external laser control. The Würzburg release also frames the cleaning as collecting bacteria and depositing them at defined